Anybody can confirm it?
Yes.
Okay, fine, thanks. So this is a thyristor bridge rectifier. In problem, it is given, and we had to find the power factor for the circuit. And how to proceed for this problem, I will tell. So let me. So this is a single phase thyristor bridge rectifier for which I will draw a circuit, how it would look like. You would be aware already, I guess. So this is a thyristor bridge, which is supplied by an AC source, and there would be some load.
सर जो लिख रहे हैं वो नहीं दिख भेज पा रहे सर।
My screen is not visible. This whiteboard, what are you seeing now?
डेस्कटॉप पर 2 स्क्रीन शो कर रहा है सर, जो कि एक पर क्वेश्चन 43 है सर, एक दूसरे साइड में जो स्क्रीन शेयर किया गया है कौन कौन सा ज्वाइन है वो।
Okay, okay. Now is whiteboard visible?
यस।
Okay, perfect. So what I was discussing, that this is the problem where thyristor bridge rectifier is required, and that is supplied by 230 volt, 50 hertz supply. Okay, let's say T1, T2, T3, T4. So in this circuit, we have to find out the power factor. So can anybody let me know what should be the procedure to find out the power factor in this kind of circuit? Anybody? Okay, so power factor is what in terms of like how it is lagging, how the current waveform is lagging from the voltage waveform, right? So, but generally in power electronic circuit, there are so many components of current. One is fundamental, on which we rely upon, which can give us the active power in majority. And other is like harmonic component of fundamental, let's say third harmonics, fifth harmonics, and so on. So power factor is the angle between V1 and IS1. This is known as fundamental power factor, or you can say uh, that cos alpha it is known as. That depends upon the firing angle. And the input power factor, uh, which is defined with uh, is the angle between Vs and Is. Okay, with Vs1 and Is1, that is known as fundamental power factor and or distortion power factor, and this actual power factor of overall circuit with overall or total component of voltage and current, that is known as your total input power factor, right? So we were asked this one, and this firing angle was provided in the problem. I hope you are able to see the firing angle provided in the problem, that is 30 degree. And it is also mentioned that it is delivering a constant DC current in the load, that is of 10 ampere. Okay, so this was the thing here. And after that, uh, I will draw some waveform of voltage and current so that you will be able to visualize the waveforms, and then you can identify easily what kind of waveform and what kind of lagging or leading is it? Yeah. So voltage is anyway sinusoidal. So Vs is equal to Vs1. There is no harmonic components. So that is the advantage of sinusoidal voltage. And its magnitude is 230 volt RMS, means 230 root 2 volt of peak amplitude. And this will be pi. Okay. Now, after some firing angle, let's say this circuit you are seeing here, and alpha was given 30 degree. So at 30 degree, T1 and T2 will be turned on. At 30 degree, T1 and T2 will be turned on, and this load would be in forward connection, right? Like this. T1 and T2 is on. T1 and T2 would be on. And here, like load would be connected and current would flow. Okay. So in this manner, this T1 and T2 will flow, and the power, but this forward current, this IS is positive. Let us assume this direction is positive. So this current is positive for this half. Let me identify this alpha, alpha. And if this current is positive and this voltage is directly connected to supply, if we can see here, there are nothing inductance or capacitance or anything else. So this V naught would be equal to Vs from alpha to whatever point this T1 and T2 would conduct. Okay. So it will start conducting from alpha and it will conduct till pi. This was pi, this was 2 pi. At least it will conduct till pi. In problem, it is said that it is delivering constant DC current of 10 ampere. Okay. So the current of constant DC of 10 ampere, it means there is no discontinuous conduction in the circuit, and hence uh, this T1 and T2 would continue to conduct pi plus 30 degree. And after that point, this T2 and T3 and T4 will take over, and T1 and T2 would be in reverse biased, and it will get turned off. So from alpha to pi plus alpha, this is the voltage waveform of output, and this is kind of voltage waveform. Now, uh, we had to calculate the waveform of this IS. Fine. So for calculating the waveform of IS, we all know IS could be in two form. Either it could be I naught or minus I naught. Why? Because this load is directly connected to supply. When T1 and T2 would conduct, this current will flow in this manner, T1, T2, and it will connect the load in this manner. When T3 and T4 would conduct, so again, T3, T4, you can see the thin line, thin red line. Okay. So it will flow in this manner, right? So that would contribute minus I naught because its direction would be the opposite of this load, right? So that's the concept here. If you see, the current is going in this direction, this direction. Earlier it was going in this direction. So that's the fundamental here. I hope you are able to catch it. If any doubt, you can stop me in between.
Sir, sir,
Yeah,
small doubt, sir.
yeah. Please go ahead.
Sir, can explain, sir, that's diagram?
This diagram, a circuit diagram, you are asking?
Yes,
Okay.
circuit diagram.
See, when T1 and T2 was conducting, so the current direction from this load side, current direction will be from A to B. Let me denote from plus to minus, right? And this would be same, irrespective of supply current getting reversed or not. For blue one, I have drawn the blue connection for T1 and T2, right? And for conduction of T1 and T2, this current direction was like this. It is getting in similar with I naught. But when T3 and T4 would be in forward conduction mode, then what will happen? You see this
Sir,
conduction.
sir,
Hmm.
sir,
Yeah, yeah, please.
sir, sir, T1 direction, up direction, down direction.
T1 is up direction, na? Let me show you. T1 is in this
Yes,
this
sir.
direction. T1. The conduction happens from anode to cathode, right? From A to
Can you
K.
repeat again?
Yeah.
Can you repeat
Any current will flow in thyristor from anode to cathode.
diagram?
So this is anode, this is cathode. So current will flow from anode to cathode from T1 and similarly in similar manner in T2, right? In T2 also it will flow in this manner. It will go in this manner. Are you able to follow this? Let me draw once again. Let me rub this.
Sir, one second, sir. Repeat again.
Yeah, yeah, I am repeating again. Let me erase the earlier part so that I will be able to show the current direction again. See, if T1 and T2 is conducting, then current direction would be this. You agree till this point? Gangadhar, you were asking, you agree till this point?
Yes, sir.
Huh. So
Sir, మళ్ళీ ఒకసారి repeat again, sir. Signal is not connected.
okay,
Can
okay,
you
okay.
repeat
Sir,
again, sir?
Yeah, sure. Yeah.
sir,
Anybody else is asking? Anubhav, yeah, go ahead.
yes, sir. Please explain the concept to us. He just create nuances control class also.
Can you repeat it? I did not get that point.
Sir, please explain it to us and then explain to him because
Okay.
he
Okay. So, Gangadhar, what is happening? Your connection is low. So anyway, I will put this recording session in on my YouTube channel. So you can access from there, or you can go to NPTEL Gate website. You can access it from there as well. Is it fine, Gangadhar? Yeah. So I hope so. It would be fine for you. So I was telling that this could be the waveform of V naught and it will repeat for other thyristor, or sorry, other cycle in similar manner. Any doubt till this point? Now, the time is to show the current waveform of IS, right? IS will be always I naught, and this was I naught. And when T1 and T2 was conducting, IS will be equal to I naught, right? From alpha to pi plus alpha, that alpha is 30 degree given in the problem. And after that, when T3 and T4 was conducting, then IS is equal to minus I naught. If you identify the current direction here, T3 and T4, it would be opposite of I naught. So let me draw this from alpha to pi plus alpha, and in similar manner for other part as well. So this is a square wave diagram which would consist several harmonics of fundamental component, and that fundamental component will also have some contribution, and I would say that would contribute majorly in any power electronics converter, and it should contribute majorly because that is the point of using any DC to AC or AC to DC converter. So uh, this blue one, what you are observing, this is IS1. Okay, this is IS1, and this VS is anyway sinusoidal, and IS1 I have shown you how you can obtain a sinusoidal waveform from a square waveform, and you can easily observe that phase difference between these two waveforms is alpha, right? Here alpha, this much phase difference between these two. So this is fundamental displacement angle, or we can say the phase difference between fundamental component of voltage and current, that is alpha, and that is also called as fundamental power factor. So this cos alpha is 30 degree, but we need to find out the angle between Vs and Is, and if you add all the components of Is, so one factor which is known as distortion factor, that would get multiplied with this power factor. This is known as G, and this total.
Sir, can I repeat again, sir? That's graph.
Uh, Gangadhar, I guess you have a weaker signal at your end. So what I suggest you, I will upload this session
Yes,
of
sir. Signal
recording.
is
Uh, Gangadhar, you can watch this session on YouTube. Recording will be available. I think your signal is very weak. So you try to
yes, sir. Weak only, sir. Signal is weak.
yeah. So on YouTube, it will not be any problem. So you can catch up from there because others will be got
Yes,
behind
sir.
you.
Can explain, sir, that
So earlier also Nubuk was
graph.
trying to say that he create motions in other classes as well. So just like
Yes.
with disturbance.
Okay. So
Yes.
please Gangadhar, you stay muted, please, because others are getting disturbed. You can access this session from YouTube. I hope it would be okay for you. So I am moving ahead. So the total input power factor would be multiplied with G. Why G? I will explain. And what is G? That also I will explain. See, IS1 and IS, there should be a relationship between these two current because both is the component of single entity, that is source current. And IS1 would be always less than Is because it is a part of Is. So there is one factor defined to relate the ratio between Is1 and Is, and that is called as distortion factor. G, this is distortion factor. Okay.
IS1 is a fundamental component of I.
Fundamental. This blue one you can see from the graph, and Is is the red one, which you can see from the graph.
Yes.
Yeah, fine. So earlier our power factor angle between Vs and Is1. Anyway, Vs and Vs1 is same, but it was contributing to cos alpha. Now I need Vs1 and Is. The angle would be same with one factor. How? This Is is equal to, you can see Is1 by G, or the relation with distortion factor. That's why this G factor is getting multiplied here. Any doubt till this point? If not, then I will move ahead and I will try
Yes,
to.
sir. Sir, please explain this again.
Okay,
Why
this.
we multiply G?
See, earlier this alpha was the angle between Vs1 and Is1, but we need a relationship between Vs and Is, right? So there is a relationship between Is1 and Is. This is the relationship between Is1 and Is. So putting, we are moving from Is1 to Is. So we need one factor like how to put it? We need one factor that will be accumulated to the power factor formula. So that factor would be G. And G is nothing but the relationship between IS1 and IS. Am I getting through?
Yes, sir.
Okay, thanks. So that was the reason to introduce this G. G is nothing, it is the ratio between fundamental and total. That's it. So how will we calculate G? That is another point. And at the end, I will tell you what is the shortcut. There is always a shortcut for such kind of problem that is known as, you might have also seen that power factor is equal to G times cos alpha. And G for this type of problem, for single phase full wave converter, G is nothing but 2 root 2 by pi. This kind of values people used to mug up, but I will show how it is coming like that. So IS1 is the sinusoidal one, and if you see this, how to calculate the Fourier series of this square wave. So let me show you this I note. So IS would be summation of n is equal to 135 to infinity 4 I naught by n pi 4 I naught by n phi sine n omega t minus n alpha. So why I am writing this expression? So if there is any square waveform, I am just telling you a shortcut. You can either derive it from concept of Fourier series. So but in power electronics, I believe that if you know Fourier series of one or two kind of waveform, you will be easily get through all types of problem because you will majorly see a square wave because the work of power electronics is to provide a sinusoidal thing, but that fails in that purpose. So it kind of tends to provide us a square waveform. So anywhere you can see that, or maybe at some point of time, I would take one session on like simplification of this kind of series, this kind of waveform, where you can just uh, there would be some tricks or ways to calculate the Fourier series. But I think you would be aware for this kind of a square waveform, the peak value magnitude of a square waveform that is multiplied by 4 by n pi sine omega t. But since it is shifted by alpha angle, that's why, and it is shifted towards right. So sorry, it should be plus, right? No, no, minus only. So I am using this concept from signal and system. If it is shifted rightwards, so it would be minus. So that's why n alpha would multiplied. And anyway, alpha would not contribute in calculating the factor of G. But this kind of waveform, you can easily derive such kind of Fourier series. Any issue till this point? So, and if I move ahead and I will try to compute IS1 RMS and IS RMS. So first I will try to write what will be IS1, and IS1 would be 4 I naught by 1 into pi because n will be 1 sine omega t minus alpha. And if I will try to take this RMS one, so IS1 RMS would be 4 I naught by pi, and for calculating RMS, we will divide it by root 2. So it will come out to be 2 root 2 by pi I naught. Any doubt this till this point?
No.
Fine, thanks. So IS1 RMS we calculated. Now we need to calculate IS RMS, right? And IS RMS for the square waveform, you would easily calculate because if you square this, so this will become I naught square and omega t. Let me tell you. IS RMS is equal to 1 by t IS square d omega t from alpha to pi plus alpha. We can take 2 by t because it is periodic anyway. So you can take this way, or you can also write like 1 by t. Since this is a half wave symmetric, so we can easily go for half period. Otherwise, you can write from alpha to 2 pi plus.
Alpha to pi plus alpha is equal to 1 by t by 2. So it means 2 by t.
Yeah,
Half.
for half time. Yeah,
Half.
you are correct. Huh? But when I am doing from alpha to 2 pi plus alpha, you can take one full cycle. Doesn't
Yes.
matter. Huh? You are right. Huh? So since it is half wave symmetry, so I will further simplify it from alpha to pi plus alpha and is a square, and that is nothing but if you do a square for this portion, it is already I naught. If you square this negative term, it will also become positive and it will again become I naught. So I naught square will be for throughout the period. So that will be I naught square d omega t. And after solving it, you will get d omega t. If you do it, 2 by t, I naught square is constant. So let me take it side. And d omega t, if you integrate from pi plus alpha minus alpha, and it will become pi, and t is anyway 2 pi, so 2 by 2 pi would get cancelled out. This term would get cancelled out with this term, and it will become I naught. So that will be your ISRMS. Any doubt? I don't think so. It should be, but you can ask. So we calculated IS1 RMS and ISRMS, and now we need to take the ratio between them. And if you calculate the ratio between them, so this would be IS1 RMS by ISRMS. So IS1 RMS was 2 root 2 by pi I naught, 2 root 2 by pi I naught. That is IS1 RMS divided by ISRMS is I naught. So I naught and I naught get cancelled, and G will become 2 root 2 by pi. So this will be your distortion factor for this problem. That's why I told this waveform is quite a common across the single phase rectifier or single phase inverter, you can say. And hence this value would be very common in your gate problem. So if you remember, it's well and good. It could save you 1 or 2 minutes in exam. Otherwise, you always approach from a standard rule. So I hope it was fine till this point, and final answer I would calculate here. So final answer would be cos phi, that was g cos alpha, and g was 2 root 2 by pi into cos 30, and that would come out to be, yeah, that will come out to be 0.78. So it would be answer to the problem. So it was asked for 2 marks in GATE 2016 in session 1. So I hope it is fine to you now. If
Yes,
any last issue in this problem, I can again discuss. So this was
sir.
asked. Yeah.
Input power factor is the angle between the source voltage and source side current.
Right.
And the power factor asked here is between
AC means.
between
It is written in the problem. AC means is written here.
no, AC means in between source voltage and source current.
Yeah, AC means is in rectifier. AC is from input side, which is source. So the source is connected to AC, and hence AC means will be, you can refer it from the problem that AC is input voltage and input current. Anyway, in rectifier,
We are calculating the input power factor, sir.
yeah, because you cannot calculate output power factor. Why? Any reason for that? Why can't you calculate output power factor in the problem?
DC
Yeah,
current is
obviously. So that's the obvious thing. In output it is DC. If it is not mentioned, it is just mentioned that it is rectifier. So you will always focus on AC side. Fine. In
sir.
inverter, you can always focus on output side. So that is the thing. Yeah.
And uh, how you from graph you say that the power factor, the angle between fundamental voltage and fundamental current is cos alpha.
Yeah. So I showed you this waveform. So you can see this waveform you can visualize IS1.
Yes, sir.
Huh. So you see, this IS waveform, it got shifted by angle alpha due to firing angle, right? The,
Yes,
re
sir.
the reason behind shifting of this IS waveform was due to firing angle. And if you draw the fundamental Fourier of this square wave, you will get the zero crossing point will come at alpha and pi plus alpha. Agree?
Yes, sir.
Huh. So Vs and Vs1, Vs is sinusoidal, so all the component of Vs is anyway fundamental. So there would not be any other harmonic component in Vs. So Vs is Vs1, Is is shifted by alpha. So the angle between Vs and Is1 is cos alpha. So that is fundamental component power factor is there. Fine.
Yes, sir. Yes, sir.
Huh. But we need a total power factor, that is angle between Vs and Is. And since this waveform would get some distorted if you add up some third harmonics as well, so all this harmonics component would be seen like that, fifth harmonic like that. So this waveform would get distorted if you add all the components. So that power factor would be shifted. So that is known as your input power factor. What will be seen from the AC mains, from supply, yeah, from your socket, your input socket, if you can see. You got in your home single phase supply, so that is AC mains. Fine, Anubhav?
Yes, sir.
Okay, thanks. Any other doubt?
No, sir.
Fine, thanks. So I hope this problem was clear to you. I will shift to some other problem that is related to machine. And one problem is based on transformer, AD current or iron loss component that was also asked in the same year for 2 marks. So let me take that problem. Uh, are you able to see the problem based on transformer? This was asked in 2016 for 2 marks. So here we had to calculate the hysteresis loss and ED current loss, and you have to write the ratio between both of them. So 400 volt 50 hertz supply of transformer was given, and it's three operating point is given in the problem. First operating point is 200 volt 25 hertz, and at that operating point iron loss is given 2 kilowatt. Another operating point is 416 volt 52 hertz, and at that operating point what will be the losses that we had to calculate. And the first operating point was 400 volt 50 hertz, and its iron loss was given 5 kilowatt. So any common thing, can you able to visualize any common factor among these three operating point, if you recall?
Hysteresis loss would be constant.
Yeah, this hysteresis
Uh,
loss would not be constant. That factor
Iron
would
losses, sir.
be, that factor would be constant throughout. So why so? Whenever this mm, V/F ratio you might have heard. So if this is constant, then your factor KH and KE, which would contribute to KI, that would remain constant. Otherwise, this factor would come from the loss formula of pH and Pi. Is anybody able to recall the expression of pH and PE?
Yes, sir.
Yeah.
Yes, sir. P is equal to K A plus square BM square, sir.
If a square,
A,
no,
no, sir.
if,
A
okay,
only A sir and B M के power x.
okay. F and Bm raised to power x.
P is equal to K A plus square BM square.
K F square Bm square. And one factor, if I would recall clearly, thickness का square.
Yes, sir.
And here
yes,
also,
sir. एक ऐसे भी डायरेक्ट कांस्टेंट लेके ये बोल सकते हैं कि P I is equal to A into A plus BF square.
and Bm is proportional to V by F. So if you put this V by F in this expression in pH, KH F V by F raised to power x, right? So if V by x is constant, let's say, then whatever will be the ratio, that would be constant. So it will not matter if V by F is constant. So this would be insignificant during that time. If this ratio is not constant, then you have to take proper thing, and then a Steinmetz constant would come in picture. This x is generally varies from 1.6 to 2. And similarly, if you put V by F ka square, then you can get it KE F square, right? So I think some mistake is there. KE BM square.
Sir, can I say, sir?
Yeah, please go ahead. I actually simply.
सर यहाँ पर B by F जो है दोनों केस में कांस्टेंट है. तो
Okay,
जो भी
yeah, I got it. So if it is constant, it won't matter here, right? That's what you want to say?
Yes, sir. Yes, sir. Yes, sir.
So it will effectively vary with KEF square. So thanks. Actually, that's quite a long time since I revised it. So that's why you guys also keep revising all the things. So, but I remember that pH varies with frequency, KH times F, and P varies with F square, that is KEF square. So hence, if you go for the high speed thing or high frequency thing, why frequency does matter in transformer? Because if you go for high frequency thing, your transformer will become a smaller and smaller. Same thing happens with motor or generator set. If you go for high speed motor, you see that your number of poles would get lower and your motor size would start to become smaller and smaller. So, but at the same times, your ED loss and hysteresis loss would also get added up. It would be significant. You see, it is varying with F square. So that is quite huge. And in motor, we try to, or in any machine, you try to take care because it might not be, quantifiable to you, but generally in machine, if you go at higher speed, this iron losses become dominant compared to your copper loss. So that's why we use this lamination, this lamination thickness. So any motor would be laminated. That a stack gets laminated, single. So for that purpose, your thickness, this eddy current losses, that depends on T square. Why? Because the smaller the lamination thickness would be, the lesser would be your eddy current loss. So do you know how much the thickness of lamination generally we use for our silicon steel or kind of modern day? How much
2
lamination?
mm, sir.
2
1
mm,
mm, 2 mm,
one,
0.
one, 1 mm, 2 mm. Okay.
0.2 mm.
0.2 mm. Yeah, you are quite close.
Around 0.35 mm.
Yeah, 0.35 is very common. That is known as material M235. And or M19 as well. So 0.35 is very common. You can easily get in India. But nowadays, since very high power, very compact motors are required, very compact drivetrains are required, so the minimum lamination steel till date I have seen that thickness is 0.1 mm. And believe me, if I am going to design a motor for like 500 kilowatt or 600 kilowatt, it improves the efficiency from 92% to 97%. So 5% of efficiency in terms of hundreds of kilowatt, that is significant. So that kind of help this smaller laminations does in electrical machine. So that's I just wanted to quantify this concept. So it is very crucial in machines, this eddy losses and hysteresis losses. So moving ahead with the problem, the 3 points are given. So I can form three equations based on pH is equal to KHF, P is equal to KEF square, and total iron loss, if I write, that would be sum of hysteresis and eddy. And I can write KHF plus KEF square, right? So I will write three equations since 3 points are given. So first was given 450 hertz and 5 kilowatt. So I can write 5000 watt is equal to KH into 50 plus KE into 50 ka square. If I will simplify it, so this KH plus 50 50, so 50 by 100 2 KE, I guess. But it is 50 KE.
बोथ साइड डिवाइड कर देंगे सर 50 से
Yeah, you divide it with 50 on both sides, so you will get KH plus 50 KE KH plus 50 KE is equal to 100. It is your first equation. And similarly, the second point is given. Let me show you. It is given at 25 hertz, 200 volts. So you can see the V by F is constant here. So that's why I am applying this direct KHF and KEF square. So 400 by 50. So that comes out to be 8. Okay, V by F ratio is 8. Let us check at 200 by 25. That would also come out to be 8. And at asking operating point 416 by 52, so that would also come out to be 8. So everywhere V by F is constant. So I will write another condition. So that's 2000 hertz, 2000 kilowatt is equal to KH into 25 frequency by 25 hertz plus KE into 25 ka square. So if you solve this equation, you will get KH plus 25 KE is equal to 80. So it will be your second equation. And if you solve this two equations, you will get KH equal to 60 and KE and KE yeah, so KE is equal to 0.8. So you can see KE factor is less because it is dependent on F square. So KE should be quite less. So that's the thing here. And now we have asked to find out at 416 volt and 52 hertz. So we know KH at 52 hertz of frequency plus KI into 52 ka square, and I will put 60 at the place of KH and I will put 0.8 at the place of KE, and after solving you will get hysteresis loss component of 3120. This come out to be 3120 and this would come out to be 2163.2. what? We were asked the ratio of hysteresis by AD. So this is hysteresis, this is AD. So pH by PE is equal to 3120 divided by 2163.2, and it is known as okay, so I will see what is it. So its ratio would come out to be 1.4423. Okay, so the answer would be this one. You just have to put in answer section. So is it fine? Any doubt in this problem?
सर अगर V बाई F रेशियो डिफरेंट रहेगा तो फिर फ्लक्स डेंसिटी दोनों केस में मेरा अलग हो जाएगा।
Yeah, flux
तो
density will be different. Yeah.
तो फिर उससे वैसे कंसीडर करके चलना जो आप देके चल रहे हैं।
हाँ, then we have to move ahead with complete formula. Then we have to
Yes.
take care of, this would come out to be KH if raised to power 1 minus X and V, why this is and V raised to power X. So this formula would work at that instant. And for AD component, this would come out to be KE V square T square, because frequency would be cancelled out. This F and this F would be cancelled out, and then it would be K V square T square. So that's
हिस्टैरिसीस लॉस ये सप्लाई वोल्टेज और फ्रीक्वेंसी दोनों पर डिपेंड करता है, लेकिन एडी करंट
iron loss depends on this frequency and voltage, mainly on flux and your resistance of that flux. So hysteresis loss is a function of your flux and frequency, but AD current is a function of your flux and density, frequency, as well as the lamination thickness. So that if a flux, let us say, I showed you in my earlier lectures that to complete one pole in any motor, the flux will flow like this. This is radial direction, right? It is going from one north pole and coming to south pole. If, let us say, there are no resistance to this section, this, let's say, axial, so some portion of flux would get leaked to axial and some losses would corresponding to that axial component. So that we want to avoid. That's why we give insulation between all the lamination thickness, the thinner laminations, and we put some insulation between them. So that's the reason of eddy current. Is it fine, Abhishek?
Yes.
Fine. So I will solve now next. Is it fine with everyone else? I hope so. I am moving to next problem now, and that is based on a DC motor. Very basic problem. I have already discussed the efficiency figure and all, so it is also based on efficiency, and it was also asked for 2 marks. And yeah, so this is the problem. I hope you are able to see. A DC shunt generator delivers 45 ampere at a terminal voltage of 220 volt. Armature resistance and field resistance was provided, and it is shunt connected. So the connection of armature shunt array RF, this would be our terminal voltage. Since it is a generator, so supply would be provided from the armature, and it would get dispersed in 2 directions. One would correspond to line that would lead to your output, and one component would be flux component. So here also 2 components you are able to see. One is flux component, field component, D-axis component. Another is the power component, that is, your line current due to VT and IL. So we need to calculate the percentage efficiency. So efficiency, we know P out by P in into 100%. So this is our efficiency figure. Now, we know that terminal voltage is VT. If we calculate IL, then we will know that what is our output power. And this 45 ampere is given. It is delivering at terminal only. So IL is 45 given. So we know output power, right? PO is equal to VT and IL. So VT, IL, that is
Is 89.79%.
89.79%. I guess it is not the answer. But anyway, let us see.
Okay.
Into 45, and it will come out to be 220 into 45. That is 9.9 kilowatt. Okay, so this is output. Output was straightforward. Now we want to move towards input, and it is generator. So input would be output plus losses, and total losses would be copper losses. Which losses will present in this circuit? Can anybody identify? One loss is given, a stray loss, that is 375 watt. Any other loss?
Copper loss.
Copper loss would be there. In which component? Which component would be there?
Field, field component and armature components.
Right, correct, perfect. So one would be IA square RA and one would be IF square RF. So a stray loss plus IA square RA plus IF square RF. So we did not calculate IF yet. So IF would be a straightforward VT by RF. VT is given. RF is also given 44 ampere. It would be 220 by 44 and it would come out to be 5 ampere. So stray was 375 plus IA will be sum of IF plus IL. So IA is IF plus IL. Once you draw the circuit, it will be very easy to identify all the component of armature, field or line. It doesn't matter. So it would be 5 plus 45. That would be 50 ampere. And here IA would be 50 ka square into RA was 0.01 ohm plus IF was 5 ka square into RF 44. So if we add all the losses, since no iron losses or mechanical losses was given, so we will ignore that and I will add it 50 square into 0.01. It would come out to be 25 and it would come out to be 25 into 44. That is 1100. So you can see significant loss, copper loss is happening in field component. So and in armature resistance, since it was very small, so negligible amount. So total losses, if I add, it can be 11 and 4, 1500, I guess. 1500 watt is total losses. And efficiency, now I will write output by 9.9 kilowatt. Again, output plus losses, 9.9 plus 1.5. And let me see, 9.9 divided by 9.9 plus 1.5. It would come out to be 86.8% into 100. 86.8%. Is it fine?
यस सर, लेकिन जब हम लोग जो जनरेट ईएमएफ कर रहा है सर, ई और जो आर्मेचर करंट है सर, अगर दोनों का प्रोडक्ट निकालते तो वो कौन सा पावर
That
कैलकुलेट
is
होगा?
developed power. That is your developed power. Let me show you. This EA and IA is developed power.
तो हम लोग इनपुट पावर यहाँ से तो डेवलप पावर प्लस लॉसेस।
See, you cannot calculate input power from developed power. Why? Because no mechanical losses are given. So then nothing is said about any mechanical losses and all. I have shown you power flow diagram. So for generator, since the problem was generator, so input would be mechanical, right? Then some rotational losses, no load current was not given. If no load current would have been given, then we can calculate no load rotational loss. So this rotational loss plus frictional and windage, okay, plus whatever the mechanical loss would be there. After
आयरन लॉस कहाँ पाएगा सर इसमें?
that I am showing you. Then after developed, this is the developed power, and after that copper loss in armature I square RA, that would come out to be output. And since the field is integrated in the circuit, so IF square RF would be also there. Otherwise, if it would have separately excited motor or generator, then this term would not be counted, IF square RF. So this you should count it very carefully. And it is self-excited. That's why we are counting it in power flow diagram. Otherwise, this field is excited separately. So this goes straight to the output. Is it fine, Abhishek?
यस, लेकिन आयरन लॉस होगा तो वो कहाँ पर कंसीडर
Acha,
किया
you are
जाएगा?
asking about iron losses. Okay. So yeah,
Yes.
when iron loss does occur? You tell me.
When ED current loss are present.
When eddy
Means
current and hysteresis current.
तब कोई लीकेज फ्लक्स हुआ, वो लीकेज फ्लक्स से लीकेज ईएमएफ इंड्यूस हुआ और उस लीकेज से लीकेज करंट, जिस लीकेज करंट से जो लॉसेस हुआ वो ईडी करंट लॉसेस हुआ सर, तो वो तो आयरन लॉस में ही आएगा।
हाँ, so basically
तो क्या
whenever power would be developed, once power is developed, okay, at armature from mechanical, you give supply from mechanical side and then power is developed at your armature. Now that power would try to transfer it to your terminal or whatever is required load. So that iron loss would appear in this stage. You agree?
सर सपोज करते हैं ऐसे कोई क्वेश्चन है जिसमें बोलता है कि आयरन लॉस प्लस फ्रिक्शनल लॉस जो है दिया हुआ है, तो वो फिर हम कहाँ पर कंसीडर कर जाएंगे? फ्रिक्शनल लॉस तो फिर मेरा डेवलप पावर के पीछे होगा ना सर?
Yeah, frictional loss यहाँ पे I have shown you. Frictional
तो
loss.
सर कोई क्वेश्चन में डायरेक्ट दिया हुआ आयरन लॉस प्लस फ्रिक्शनल लॉस जो है इतना दिया हुआ,
Then if something mixed up thing was given, then you focus on these two things. One is output, one is input. So output, you add all the loss component and you will get input, right? You do not need to worry about this state. And in this
yes.
problem also, I did not worry about intermediate state. This intermediate stage is important when you go into induction motor and synchronous motor. Sometimes in DC motor as well. But if you know the basic flow chart, how you move from a stator to, input to output, then it would be okay for you. Fine?
Yes.
You try to, visualize where the mechanical losses would occur, where electrical losses would occur. What is the flow chart from electrical to mechanical, mechanical to electrical. So that kind of visualization is necessary because generally in machine, no visualization you can do easily until and unless you go to some power plant or so. So that's why I tried to show you some model of machines so that you can get a better idea. Or anything you want, I can show you at any point, like whatever you want to see from simulation based, because I have access of that as of now. So for that purpose only, I sometimes use some simulation tools as well too, because machine is very, in UG, we study it in abstract manner. So that should not be the approach, but that is what it is. So fine then. And Abhishek, you have sent me one problem. I guess tonight it is the time, but anyway, if you I think it would be better if I will discuss that problem with everyone. So what I will do in the beginning of next session, I will discuss your problem. And can you tell me what the issue you are getting in that problem? Because I kind of see that problem and it did fine okay to me.
सर उसमें प्रॉब्लम ये हुआ है कि जो मैं एंगल दिया हुआ है पोल्स हुआ है जैसे ये डीसी जनरेटर में सर मुझे ये प्रॉब्लम हुआ कि जैसे पोल आर्क दिया हुआ है पोल
हाँ
पिच दिया हुआ तो उससे मुझे एरिया निकालना है जो कितना वो फ्लक्स डेंसिटी निकाल रहा है वो उस एरिया से कितना निकाल रहा तो उस क्रॉस सेक्शनल एरिया को कैलकुलेट करने में मुझे दिक्कत हुआ है
See. I will tell in very short, and you try to catch it up. Otherwise, we will discuss in next session. So, this is pole pitch. This will be pole arc, right? Let's say this is pole arc and this is pole pitch. Fine. And if this is the case, then to calculate area, you will always consider this portion only. You need not take off this portion. You just consider this portion because that is contributing to your air gap flux, right?
Yes.
So in that problem, it was given it is 60 degrees subtended, means total effective area you calculate for entire pole and you multiply with 120 by 180, this one half pole pitch. You calculate one pole pitch area and you multiply with 120 by 180. That would be your effective area. And you do that, you will get that answer. You got it?
ये सब जैसे एक रेशियो दिया हुआ सब आर्क टू पोल पिच में कितना उसका रेशियो है सर
That is 60 degree means 2/3 part is pole pitch and 1/3 is not contributing to air gap flux density.
तो इसको थोड़ा क्लियर नहीं हो पा नेक्स्ट क्लास में देख
in next class we will discuss it properly.
क्योंकि another session स्टार्ट हो चुका है सर.
Okay, yeah, sure. You go ahead and join. Thank you everyone. Thank you very much for attending.
थैंक यू.
Yeah.
Thank you, sir.
जो
Thank you.
पहले प्रश्न था वो आंसर मैच नहीं कर पाया.
Okay, that we will also see. I think that mail you sent late, so I did not see that mail. I was in another meeting. So I will discuss both the things. Thank you everyone. Thank you. Bye.